Hey, whilst Dragon Metals here. Today I am scrapping 6-volt lantern batteries. That's these things. I've already done 3, as you can see. Got this one on the vise ready to be cut up. This is the material that I'll be getting out of them, which is lead-antimony, which is lead alloyed with antimony, which is quite valuable. That white stuff you see everywhere is sodium bicarbonate, which is neutralising this stuff. Guess what that is? Yeah, that's 1% sulfuric acid in there out of the batteries, which I will be collecting for use with gold recovery, gold testing and other chemical experiments. There's only 1% in there, but it is diluted with lots of distilled water. You can make it stronger, however, just by boiling off the water. And there's some lead antimony plates, ones that are completely corroded into mush, like this is. The acid does that over time. So I need to find a good angle for this. I'll do nicely. So gloves and goggles. Definitely required, as well as sodium bicarbonate, just in case there's any spills. Pretty much covering everything with sodium bicarb in order to reduce any spillage or bleeds. Scoring around the edges with the hacksaw on the epoxy seal. Just be a bit tighter. Kind of hard to work with these thick gloves on. They do help protect from a vast variety of things. Scored through there, now I need to score on this side. And on the other. And I'll extract the plates. And I've already done the acid, which is just poured out, and maybe a little bit left within the sponges. Okay, you can either pull this out in one or saw all the way through. I usually saw all the way through. Otherwise you end up pulling out all the cells in one go, which I don't want. Lost the hacksaw blade. Keeps happening. Does not agree with sulfuric acid to harden steel. It's the second blade that I've lost. And this is only ABS plastic, so it's not tough. It's basically drain pipe material. So it's the acid that's doing it. So new blade. Another new blade. Well, the first one I had was pretty old. Still, third blade in. Sawing through the lead also, really soft. There. There. And there we go. Top is off. A little bit of acid left in there. Cool. Right, with my sodium bicarb. I can handle that. See there? All that bubbling? That's the sulfuric acid there being neutralised. And that is why you need bicarbonate to neutralise it. A good source of alkynes needed. neutralise the acid. Just taking off the cathode parts that connect to the top here. Very soft lead antimony, you can just literally twist it off, as you can see. Very buttery metal. One of the softest, up there with indium, but not as rare. Indium's basically a rare earth metal, even though it's actually pretty commonly used. Things like TV screens, touch screens. Digging out the last bit with a screwdriver. I will melt all this down probably into ingots also. See what I get out of all the lead antimony plates. Do that another time though, as the weather's probably going to change. It's nowhere near as warm as it was, and the wind's been picking up the last few days. Not surprised after a week of sunshine. So let's have a look inside the battery. Very, very corroded. You can see all the iron there. Those bits, they'll just literally fall out. Which I'll need to do in this little buckety thing. Gloves. Got my gloves there. That would be a bad idea. These gloves are already wrecked from foraging. Good choice. Oh. Stuck that nice. There we go. And some bits of broken lead there. Lead antimony. That can go on the pile. All that will need to have sodium bicarb sprinkled upon it in order to neutralise any remaining acids. So I'm going to pull the cells out of this battery now. There's 3 cells per 6-volt battery, each making 2 volts. That's lead and iron for the anode and cathode. There's a chemical composition in the side, which is sulfuric acid, which makes electricity. It's electrolytic reaction. Pull that cell out. There's quite a bit of acid left on that. Give that a squeeze. Over here though. Okay. Sodium. I'll neutralise the acid on my gloves. Some more cell left in there. These gloves are not very nimble. That's just sponge with sulfuric acid within it, and a few disintegrated cells. Try and get them out. Usually have issues with this stuff. Oh, I got it. It's all disintegrated the cell. Collect what I can. But it's very corroded in these batteries. There's the sponge. Okay, so the material of that dead lead plate out there, heavily corroded, not good use at all. There we go, that's the lead plate there. There's another one on the opposite side. There's another bit inside, however, that's all corroded. All that stuff just fall out. That is in fact lead antimony, but it's all heavily disintegrated. There's a partial chunk of plate there. That's what it looks like once it's disintegrated compared to the whole piece. It's actually quite hard work this, since the lead is surprisingly heavy, as one would expect. It's also quite valuable. There you go, the cell has been emptied. Now, to extract the lead plates. This sponge material here contains sulfuric acid, which I will be not going here, ideally. However, there are plates of lead stuck to it, which I will want to extract carefully, such as that, which just fell apart. Probably take the sponges out and then drop this material there. It's quite good condition, this plate. There we go, that's disintegrated. Half of the plates are in good condition, the other half are completely disintegrated from electrical reaction. As positive to negative will rust these plates into nothingness. Hair in my face. Put these aside just for a second. I want to get to the antimonal plates. These acid containing sponges, which I may or may not squeeze out into that liquid. It's all disintegrated very badly. A lot of lead antimony. Yeah. A lot of good material in here, however, and a lot not so good. It's very gunky and contaminated. This is sort of coming apart, this plate. I've got to be careful with this one. Got it. Come on. Oh no, don't fall pieces. And that's what a corroded plate looks like. See if I can get that off without got it. Put that on a pile next to the vice, which I'll show shortly. Remove that acid containing sponge. There's another nice plate of lead antimony there. Good weight for these things, of course. Another plate to go. I have to dry these also, as I said, it's only 1% sulfuric acid, the rest is distilled water, as is with most chemical lead acid batteries. That's all the lead antimony just falling off. Acid within these sponges. Gunky ones aside. All that is lead antimony in there, which I will shift this pile into carefully. This will all need to be dried, and it will also need sodium bicarb sprinkled upon it to neutralise any remaining acids. So, There's some of the material. Very, very dirty looking at the moment. That will all need to be dried and cleaned. Some clean plates over here. A number of. Good weight to them. And the acid containing sponges for the sulfuric acid, which I'll do next. Good wealth of materials for chemical experiments inside of batteries, of course, of this kind. The lead can be very useful. Lots of acid there. That'll do. Gloves off. Not contaminated, and cover myself in bicarb. That's this white stuff, which I'm literally saturating the work area with. So there's the sulfuric acid in there. So as you can see, it's very, very gunky at the moment. I will need filtration. Dropper bottles. Got another one there. Only have one label at the moment though. As you can see, this is very convenient to use a dropper style bottle, as it definitely won't spill upon you. Also, larger contaminated bits floating within the acid itself won't go inside the dropper. You can get these droppers for all sorts of uses, like that oil you put in your ears, or CBD oil, things like that. Which is this was actually from clove oil. That stuff you have for toothache. This bottle is very nearly full. All this will need to be heated. My goggles just fell off, not ideal. Do need these, definitely. Splashbacks. Well, the rest of you can handle the acid. I certainly cannot. They're all squishy. A little bit out of there. Okay. See that? That's the acid touching sodium bicarb. Which I'm going to cover the bottle in. See that bubbling away on the side? Don't want that. Do need to clean that actually. Put the label upon it. Just clean it in some grass. Right. Where's the label? I need to make more of these labels. That double-sided sticky stuff. It's not double-sided. Okay, let's do the other one. Might as well. There's actually quite a bit left in here, so I think I'll have to use another dropper bottle. I've got a couple behind me of these brown glass things. There's quite a lot of contamination in this acid, I can see floating on the top. Dead insects and all sorts of stuff from my garden. Bits of mud in the battery. So that one's filled. More bottles there. Oh. Nice big one there. I think I'll use that. Try and pour it in there actually. Oh, that bird's really happy. Very tweety bird. Carefully pour this, as carefully as possible, into its little, let's say no, while missing all that gunge at the end. That's it. Gunge mist. All the gunge remains within the solution. And we have a few bottles of sulfuric acid for chemical experimentation. Also good for gold tests and things like that. 4 batteries for all this material. Got a box full of lead antimony there. And one full of lead antimony with corroded plates here that I'm drying. Also have to treat the entire area with sodium bicarb to neutralise any acids. So I'll close that up. And I'll show you what I mean with the acid reaction, as there is some remaining within here. So let's angle that down to the jar, to the pot rather. It's difficult with my phone stand. So there's the sulfuric acid. Let's take a bit of sodium bicarb, cupful perhaps, cupful sodium bicarb. Now watch this reaction when it neutralises the sulfuric. See that? Bubbly bubbly. And that is why you need sodium bicarb, to neutralise sulfuric acid, which is no longer a danger now. In fact, it's become fertiliser. Now it would be good for your garden plants, that material. Since it's high in alkaline now. So that was scrapping a 6 volt lead acid battery, lead antimony and sulfuric acid, which I have 3 bottles of now. Still need to process that to a higher strength, as 1% isn't that powerful. So just boiling off the water would do that. Anyway, till next time.